This is Mrs. Gill. Welcome to our review lesson on rational numbers. We're doing fractions and decimals. This is grade 7 and 8 review, so hopefully it comes back to you as we get going here. And you have a handout to go along with this. So if you haven't printed out the handout yet, please do that or download it or however you're going to work with it, or you're making your own notes on your own paper to go along with what you're learning today. So first of all, what's a rational number? Rational numbers can be made by dividing two integers, and that was our last review video, was about integers. So like -7 and 5, those are integers. So if we put one over the other, we have a rational number. We're going to start with adding and subtracting rationals. We're looking at ones with the same denominator or with different denominators. So first of all, these ones all have the same denominator. That's the bottom number. They all have an 8. So when the denominator is the same, the math is pretty straight. It's the easiest kind you can get for fractions. First of all, remember you have to start each line with an equal sign, and we have to write below, not beside. So all I'm going to do is put the single denominator 8 because they all have the same denominator, and then I've got 1 minus 4. These two negatives together here make a positive, so that becomes a +3, and then we just add and subtract, and we get 0 over 8. So 0 over 8 is better written as 0. But if you had 8 over 0, that's not equal to 0. And if you have a calculator, you can try that out. It will tell you some kind of an error message. And we'll talk about that more later in the course, why 8 divided by 0 is not 0. But 0 divided by 8, certainly if you had 0 pizzas divided by 8 people, everybody's getting 0 pieces of pizza. Whereas if you had 8 pizzas divided by 0 people, well, there are no people to answer the question with. There's 8 pizzas divided by 0 people, so it's kind of an undefined situation we'll talk about later. So what about it if they have a different denominator? That's much harder. We're going to do 3 examples like that. Looking at the first one, we have 1/2 plus 1/8. So the common denominator is what we're looking for first. Let's go over some terminology here. A proper fraction is what we see here. A proper fraction is when your numerator, your top number, is less than your denominator. A mixed fraction is like this, when we have a whole number as well as a fraction. An improper fraction, I'll show you what that is, and then equivalent fractions, we'll talk about that too. But first of all, these are both proper fractions. So the first step in adding and subtracting is to convert mixed fractions to improper. Well, I don't have any mixed, so I can skip step 1 here. Let's go to step 2. Step 2 is find a common denominator and change their numerator. So what is the common denominator? We have a 2 and an 8. Now, we often hear the phrase lowest common denominator. Sometimes that's confusing for students because they want to take the lowest number, and that's completely not true. I mean, 1/2. Look at the 2. Think of 2 as being lower than 8. That's not what we want. We actually have to go at least with the biggest number we have. So even if I had a 100 denominator here, my common denominator would have to be at least 100 or higher. So you always look at your biggest number first, 8. So 8, could 8 be the common denominator? What I mean by that is there a way to take 2, multiply 2 by something that would give me 8? And it is. 8 is our common denominator. So what's our numerator going to be? So what I'm thinking is I had to multiply 2 by something to get to 8. So what did I multiply 2 by to get to 8? 2 times 4 is 8. So since I had to do 2 times 4 on the denominator, I have to do the same thing to the numerator. 1 times 4. So my numerator is going to be a 4. These two fractions here, 4/8 and 1/2, they are equivalent fractions. These are exactly the same thing. That's why I'm allowed to do that. In math, I can't just change numbers if I want to. If I had a question with a 32 in it and I didn't like it, I couldn't just make it a 33. I have to keep the same number. Here's a 1/2, here's 4/8. They are the same. They are equivalent. That's why we're allowed to make that change. So what's next? We can put them together because we have the same denominator. We have a common denominator, so I only need to write it once. I don't need to keep writing them out separately as I did here. I only need to write them once. And now my step 3 is to add or subtract. So I look at my numerator, 4 plus 1 is 5. So I tried to make these colors here match these colors here so you could follow the steps a little easier. So the green matches the green here. So 5 over 8 is our final answer. Now, can you tell me, is that proper, mixed, or improper? Hopefully you can recognize that that's a proper fraction because the numerator is less than the denominator. It's proper. So we don't need to do step 4, which is reduce to lowest terms if necessary, because for two reasons. One, it already is a proper fraction, but the other is that there's nothing I can divide 5 by and divide 8 by equally. So I can't divide them both by 5, I can't divide them both by 2, I can't reduce this fraction to lowest terms. It already is in lowest terms. 5 is a prime number, so the only thing I could divide 5 by other than 1 is 5. And if I can't divide the other number by 5, then I'm in lowest terms. So next question here, we've got a mixed fraction. So just a quick recap. Now you can, if you've forgotten any of this stuff in grade 7 or grade 8, you can look for YouTube videos and you'll see lots of help on how to do this. How do we convert, step 1, convert mixed fractions to improper? So I've got this 2 and 5/7. So here's an example. Here, 4 and 1/3. We multiply the whole number, that's the 4, by the denominator, that's 3. So that's this first arrow here. So I'm going to do multiply 4 times 3. So in my head, I know 4 times 3 is 12. Then I add the numerator. So that brings it to a 13. Keep the same denominator, that's important. So this was a denominator of 3. This is now a denominator of 3. So let's do the same thing here. 2 and 5/7. I'm going to multiply these two together. Let me write it in here. So I'm going to do, I always think of it as kind of going around in a circle. I do 2 times 7, multiply those, then add on the 5. I kind of go around in this direction. Multiply, add. So 2 times 7 and then add on 5. What's that going to be? You've got it worked out. So again, you should be doing this without a calculator, this math. This is 19 over 7. 2 times 7 is 14. 14 and 5 is 19. So we've got 19 over 7. So we've got the first step done. That kind of yellowish color is done. We've converted the mixed fractions to the improper. What's next? Step 2 is find a common denominator and change their numerators. So what's the common denominator between 7 and 4? Looking at these two, what's common to those? So we've got to look at least the biggest one. So I've got to go at least a 7 or higher. I'm going to have to go higher. So I can't take anything less than 7. 7 is not common because 4 times 2 already is 8. So I can't go with 7. You can always, if your multiplication tables are failing you and you're having a hard time figuring out the factors, the easiest thing to do is you can multiply these two together. 4 times 7 will give you a common denominator. It may not give you the lowest common denominator. In this case, it does. It may not, but it's still a common denominator. So our common denominator is 28. Now we have to figure out our numerators. So the numerator, what did we do to this 4 to get to the 4 denominator to get to a 28? How did we get from 4 to 28? What did we do? We multiplied by 7. So I have to do the same thing to the numerator here. I have to do 3 times 7. So I'm going to have a 21 there. And again, what did I do to a 7 to get to a 28? How did I get from a 7 to a 28 for a denominator? I multiplied by 4. I have to do the same. Now that number's a little bigger, so you might need to go off somewhere on some scrap paper and work out 19 times 4, however you want to do your multiplication. And we're going to get a 76. I see I've got a little typo here. This changed, should be a minus sign, not subtract there. Minus 76 over, now let me erase some of my stuff here so that it's not messy. Okay, now remember you can pause the video anytime. If I'm going too fast, that's the benefit of this online learning. You can slow it down to your pace as we go along. So what do we do next? We are on the red one here, add or subtract. So we can put everything together, and when we add or subtract 21 minus 76, we get negative 55 over 28. is that in lowest terms? So they both got lots of factors, right? I could divide 55 by 5 or by 11. I could divide 28 by 4 or by 7 or by 2. But none of those numbers that I said are common to both. So I can't divide them both by a 2. I can't divide them both by a 7. So this is in lowest terms, and it is a proper fraction. So I can just leave my answer like that. We're going to move on to C now, and if you think you have the hang of this, if you want to press pause, go ahead and work it out for yourself, and then you can come back and watch me do it if you'd like to try. But before we do, I just want to point out the difference with this one is a negative sign here and a negative sign here, or subtraction and a negative, but the two together make a positive. So my first step is just to put the two signs together into a positive. And now I'm on to step 1. Convert mixed to improper. Okay, I don't need to do that. I don't have any mixed numbers here. So I'm down to step 2. Find a common denominator and change their numerators. And remember, all you really need to do for a common denominator is multiply your two denominators together. Multiply these two denominators together, you'll get a common denominator. Sometimes it'll be too big. This time it's not. We get a 20. So what are the appropriate numerators for that? Okay, so that's, let me erase this. The appropriate numerators. What did I do to this denominator to turn it to a 20? I multiplied it by 4, so I have to do the same to the numerator. 2 times 4, I'm going to get an 8 here. And because remember, these are equivalent. 2/5 and 8/20 are equivalent to each other. I'm not cheating. I'm not changing the question. To get from a 4 to a 20, we multiply by 5. We do the same to the numerator, and we have a 5 there. So now we can put it all over one denominator. We don't need two pieces anymore. We can push them together into one denominator, and we're on step 3, add or subtract. 8 and 5 is 13, and it is in lowest terms. 13 is a prime number. It has no factors other than 13 and 1, and 13 doesn't go into 20. So that is in lowest terms. So there's your recap of adding and subtracting rationals. So luckily, adding and subtracting is the harder portion. Our next section is a little easier, but this one, make sure you do lots of practice so you remember how to add and subtract fractions. Multiplying and dividing. There's one important thing to remember about each of these operations, and we'll go through them as we do the questions. So we've got some multiplication practice and some division practice. We're going to start with multiplying. 4 over 7 times 3 over 5. Okay, so let me get a pen here. 4 over 7 times 3 over 5. The rule for multiplication is we multiply straight across. Numerator times numerator. Denominator times denominator. So I'm going to take this numerator times numerator equals sign. 4 times 3 is 12 over denominator times denominator. 7 times 5, 35. So that's all there is for multiplication and division. And then you check to see if you can reduce anything. It almost looks, it's a bit tempting to want to divide them both by 3. Maybe 3 goes into both of these, but it doesn't. So 12 over 35, there's nothing that goes, so the factors of 12 are, we don't include 1 for this process. We've got 2, 3, 4, 6, and 12. Those all go into 12, but none of them go into 35, so I cannot reduce this fraction. So let me just erase all that because it's in the way of our next question here. All right, B, 8 times 5, numerator times numerator, right? 8 times 5, that's going to be a 40, over 3 times 2 is 6. So right away I noticed that those are both even, and when your numerator and denominator are even, you can for sure divide by 2. Maybe we can divide by something bigger than 2, but we can divide by 2 for sure. So let's start with that. We divide them both by 2, and we get 20 over 3. Now, can we divide them by anything? Again, the only other thing would be a 3 if we could divide them both by 3, but we can't. Now, if the question doesn't tell you to leave your answer in mixed or improper, this is improper right now, and you don't have to change it. But let's just practice going to mixed. So we want to put 20 over 3 as a mixed number. This one is improper right now. A mixed number, it's got to have a denominator of 3. So how many times does 20 go into 3 evenly? It goes in 6 times. So 6 times 3 is 18, and we subtract that from our numerator, we're going to have 2 left over. So again, this is something, if you don't remember how to do this, you can look it up. Next question, we've got a mixed number this time, and it says here, change to improper fractions. So we're going to change these both. 3.5, first of all, I do 3 times 2, 6 plus 1, 7 over 2, times, and I'm going to change it to a dot. If you remember from the last video, I said we can use a dot instead of an X if we want to. So 2 times 3 is 6, plus 1 is 7. Again, over 3 this time. So now we can go to the step where, this step up here, where you just multiply. Numerator times numerator, denominator times denominator. And we get 7 times 7, 49. 3 times 2, 6. So 49 over 6. Let's reduce that one to a mixed number. How many times does 49 go into 6? It goes in evenly 8, and that leaves us with 1/6 remaining. Next question says divide. So divide, we have new rules for divide. The important part about dividing is we invert and multiply the second number. So if you have a over b divided by c over d, that's the same as a over b times, and we flip this one, d over c. Only the one after the division sign gets flipped, not the first one. So I'm going to first rewrite this as a multiplication question, and we later get into why is that? Why we divide fractions? So we're going to change this to multiplication. So I have to flip this, and I have 7/3 now. So when I multiply that, I'm back to multiplication, and remember multiplication straight across the top, multiply straight across the bottom. 4 times 7 is 28, and 5 times 3 is 15, and we'll leave this one alone. It's an improper fraction, but we won't change it to mixed. We'll just leave that one. We'll do some more practice with that in a minute. Next one is another pretty straightforward division one. Now's a good time to press pause and do B yourself. Just take you less than a minute, and then come back and see what I'm doing. So we are going to rewrite it first as 3/8 times, and I'm going to use a dot this time for times, 5 over 2, because remember that's the rule. You invert, which means, I'll write it up here over the word invert, which means flip or reciprocate. Sometimes you hear that word. Multiply by the reciprocal. So now I multiply straight across the top, I get 15. Straight across the bottom, I get 16, and that one's a proper fraction, so we will stop it there. Next one's a little different, because our first number 7 isn't a fraction, but remember the definition from the very beginning. A rational number is any number that can be written as a fraction, basically. So this is rational. This is really 7 over 1. There's an invisible 1 there under any whole number. If I give you any number, even if it's a negative 26, that's really negative 26 over 1. So that invisible 1 is there. So I'm still going to follow the same pattern, but I'm going to write it looking like a fraction. It's a little easier for me to work with fractions when everything looks like a fraction. Change division to multiplication. Change 1/2 to 2 over 1. And 7 multiplying straight across the top, I get 14. Straight across the bottom, 1 times 1 is 1. And in lowest terms, that's just a 14. So when you're done your question, if you're left with a 1 for your denominator, then you just drop it off and write the integer as it is. Next one, we're starting off again with a mixed number. We're going to have to change it to an improper fraction here. So let's see if you can see this color all right. Yep. So I do 2 times 5, that's 10, add on 3, 10 plus 3, 13, and my denominator is 5, divided by, what am I dividing by? I'm going to leave it division for a second here. This divided by 5, that's really 5 over 1, right? Remember we did that on the previous example? So this time I'm going to, I wrote in an extra line there. You don't need to write that extra line, but I just didn't want to skip any steps. Now I'm going to change it to multiplication, and it's 1 over 5 because the invert and multiply. So 13 over 5 times 1 over 5 multiplies straight across the top. That's a 13. Straight across the bottom is a 25. That is in lowest terms. 13 is a prime number. It can only be divided by 1 and itself by 13, and 13 doesn't go into 25. If it were 26 it would, but it doesn't. So we stop there. Last one is the most complicated one on the page, so it's a good one to pause, try it yourself, and then come back and see if you got the right answer. But if not, it's a little tricky, so let's work on it together here. My first step is to change my mixed numbers to improper. 3 times 5 is 15. Add on another 3, 18 over 3. I'm going to leave it division for one line here. 2 times 10 is 20 plus 1, 21 over 10. So now I can change it to improper, so now I can invert and multiply, or multiply by the reciprocal. So the first number stays the same. The second number flips, 10 over 21. Now we are on to multiplication, and we have some big numbers. We haven't really had any big numbers here. So there is something we can do. Oops, I made a mistake. That should be a 5, not a 3. You guys are probably at home thinking, that's a 5. Why did you change to a 3? That was a mistake. Sorry. 5. By the way, if you ever come across a mistake that I made and I haven't caught it as I'm teaching, please send me a message so I can fix it, because it's just frustrating when you're watching a video and you can't ask what's going on. So yeah, let me know if I make a mistake. Okay, back to this question. We've got 18 times 10. I think all of you could do that easily. You're just going to put a 0 on that. That's 180. Now there is a method called canceling, which we will learn later, but will help us reduce the fraction. Right now we won't do that. We're just going to multiply straight across the top, straight across the bottom. 5 times 21. If you can't do that in your head, then you're working it out. 5 times 21. 1 times 5 is 5. 5 times 2 is 10. 105. So we have 180 over 105. So that definitely can be reduced. I can tell just by looking at it that 5 is going to go into both of those. Anytime you have a number ending in a 0 or ending in a 5, you can divide them by 5. So let's divide them both by 5. See how far that gets us. I'm going to divide the top and the bottom by 5. 180 divided by 5, so you might need to work it out to do your division. 180 divided by 5. But we'll get 36 there. And 105 divided by 5, we just did that. Remember right up here, we just did 5 times 21 to get 105. So, whoops, to get 105. So we're going to get our 21 back again there. So it turns out we're not in lowest terms yet, which means instead of dividing by 5 up here, we could have actually divided by something bigger than 5, but that's okay. We're going to keep going until we get it in lowest terms. I can divide both of these by a 3 now. So dividing them both by 3, 36 divided by 3 is 12, and 21 divided by 3 is 7. So we have 12 over 7, and I'm going to just put it, I don't have much room here, I'll just put it beside. That's equal to 1 whole and 5 sevenths. So there is, if you did that on your own and you got 12 sevenths or 1 5 sevenths, that is fantastic. Congratulations, because there was a few little tricky parts in there. There is some multiplying and dividing for you, and we only have one slide left to go. Part C, that's our last part for today, converting between back and forth between decimals and fractions. That's what we're doing here. And this helps us to understand what a rational number really is. So we're only given the decimal here, 2.41. Now rationals can be written as decimals or fractions. So let's figure out how to do that. How do we get it from a decimal to a fraction? First of all, we've got two wholes. So I'm going to write that down first under my fraction box. We've got two wholes. Now 0.41, that 0.41 is there's a 4 is a tenth, 1 is a hundredth. So we've got two decimal places, which means I'm going to do a fraction, a mixed number here, and my denominator is however many decimal places I have. I have two decimal places. That means I need a 1 with two zeros there. So if I just had a 0.4, it would be over a 10. If I had a 0.415, it would be over 1,000. So that's 41 over 100. And 41 over 100, if we could reduce that, we would, but we can't. So we're going to leave that as 41 over 100. Now let's go over to the percentage column. 2.41 or 2 and 41 over 100. So ignore the 2 for a second. If you had 41 out of 100 on a test, that would be 41%. But you have two wholes on top of that. So this is 241%. Next one, we're given 9 3/4. 9 3/4 as a decimal. How do we convert it to a decimal? So there's some that you should really know. You should know that 3/4, and literally, if you think of having money in front of you, if you had 3/4 in front of you, that's 75 cents. So that's going to be 9.75. But if you couldn't make that connection, or you don't know that one, or you get stuck with one like that in your homework, what you want to do is get a denominator like we had above. We would like to have a denominator of 100 here. So just looking at the 3/4, ignoring the 9 for a minute, I need a denominator of 100. So how do I get from 4 to 100? I multiply by 25. Do the same to the numerator, multiply by 25, and you get the 75 there. So if you already know 3/4, that's perfect. 3/4 is the same as 0.75. If not, that's what you do to get your answer. But we also have the 9. Now as a percentage, again, if I had 75 over 100, that's 75%, but we also have a 9 in front, so this is 975%. The last thing, we're going to find 12% of 28 without a calculator. And yes, no calculators. You are going to have an evaluation on all this work from grade 7 and grade 8. And you will have to be able to do it without a calculator, so please don't use one. 12% of 28 without a calculator. Remember that of means something in math. Remember yesterday we talked about certain words. Sum, we said, was adding, difference was subtracting. Of means multiply. Of means multiply. So what that really, I'm going to write that as, I'm going to convert it to math. I'm going to change the of to a multiplication symbol, and we do not use the percentage sign. This is English. That's an English construct to use that and to say the word percent after it. In math, what we do to get rid of a percent is we divide by 100 or move the decimal 2 spots to the left. So 12% is really 0.12. That's what 12% is. Just like if you look back up over here in the chart, just look at the 0.41, ignore the 2, 0.41, that's your 41%, right? So the decimal is moved twice from there, so if you ignore the 2. So 12% is 0.12, of is multiply, and then 28. So I'm going to have to multiply this out without a calculator. So why don't you try that, and then I'm just going to put the answer down. So try that without a calculator. Okay, did you get an answer? And think about your answer here before I write it down. You're getting 12% of 28. So let's say you had a test out of 28 and you only got 12% on your test out of 28. So look at your answer. Does that make sense? I know you have a decimal in it, but it should be a small number. If you only got 12% on a test and you had a test that was out of 28 marks and whatever you got on your test was only 12%, that should be a small number you're getting there. So take a look and make sure you put your decimal in the right spot. You should have 3.36. That's the end of our recap of fractions, adding, subtracting, multiplying, dividing, and converting to decimals. So you've got some homework. You have handouts, and these are the questions I want you to work on. I just want to go over what this means by odd. 1 to 8 odd means question 1, you're going to start with A, not B, C, not D, E, not F, and so on. It doesn't mean you're doing the odd numbers. It means you're doing the odd letters. So 1, 2, 3, 4, 5, 6, 7, 8. You're doing all of those numbers, but you're only doing every second letter. Same thing down here. 1, 2, 3, and 4, A, not B, C, not D, and so on. And then we'll skip over to number 6 and do the odd letters. If you find that you are struggling with every question you do A, you're skipping it, you do C, you skip it, you do E, then maybe you need to go back and do all of them. So you can certainly do more than what is here. Answers are provided. That's for you to check your work. It's not so that you just get a question and you write down the answer. You have to show me work, like this kind of thing. If you don't show me that you've done any work, then I might think you just wrote down the answers or you just did it on your calculator and you really don't know what you're doing at all. And we need to determine now if you understand this material or not. So ask me questions if you have them when you're stuck. Do lots of practice and lots of questions, and feel free to watch the video again, and you should have some good notes there on your handout. Good luck.